Alright guys, so today we're reviewing Unit 9 for chemistry, and this will be on gases/gas laws. So yeah, let's get right into it. So it says, compare the intermolecular forces of the two substances at STP. So the two substances here is ethane, which has a boiling point of negative 89 degrees Celsius at STP, and then ethanol, which has they say has a much higher boiling point than ethane at STP. So intermolecular forces are just the bonds in between molecules in these substances. And so if you have a much higher boiling point, what that means is it's going to take a lot more energy to break those bonds, right? So if it takes more energy to break those bonds, it means the bonds are stronger, and so the intermolecular forces of ethanol are stronger. There you go. All right, number 2, a liquid boils when the vapor pressure of the liquid equals the atmospheric pressure on the surface of the liquid. Based on table H, what is the boiling point of ethanol at STP? So for this question, we can just take out table H, and then we're going to go down to STP and see where it lines up. So we can see on the dotted line where it says 101.3 kPa, that line intersects at a point with ethanol, right? So then we can go down here and see what temperature that lines up with, and we can see it's around 80 degrees Celsius. So our answer is 80 degrees Celsius. Number 3, show a numerical setup for calculating the volume of the gas in cylinder B at STP. Alright, so it looks like we have cylinder A is a movable piston and has hydrogen gas. And cylinder B is the exact same thing, except it has methane gas. And then it looks like between the two gases, the pressure is the same, the volume is the same, and the temperatures are also the same. So if we want to find, if we're just looking at cylinder B, right? So these conditions, the pressure conditions right here and the temperature conditions are currently not at STP. So for STP, the temperature is 173 Kelvin, and then the pressure is just 1 atmosphere. All right. So in order to solve for the volume, because right now we don't know what the volume is at STP, we will have to use the gas laws equation. And the gas laws equation is just pressure of 1, volume of 1 over temperature of 1. So these are just the initial conditions. So we know all three of these variables. And then we're just going to set this equal to the pressure of 2. In our case is 1 atmosphere over the temperature of 2. We know it would be 273 Kelvin for STP conditions. And then we're just going to solve for the final volume here. And so if you plug in the numbers, you should get that. So we only need a numerical setup. We don't actually have to solve for V. Number 4, state a change in temperature and a change in pressure that will cause the gas in cylinder A to behave more like ideal gas. So you're just going to have to know this off the top of your head. So ideal gases, they want to have high temperature and lower pressure. Now real gases, in contrast, have lower temperature, are closer together, and therefore have high pressure. But ideal gases, you want high temperature and low pressure. Number 5, compare the total number of gas molecules in cylinder A to the total number of gas molecules in cylinder B. So this is you're gonna really have to read in between the lines here. So if we look at the volumes here, we have 1.25 liters of gas here and 1.25 liters of gas here. And since pressure and temperature are constant between the hydrogen gas and the methane gas, because the volume is the same, you're also going to have the same number of gas molecules, right? So the amount of gas molecules is going to be constant between the two as well. So it is the same. All right, number 6. Compare the total number of gas particles in the sample under the initial conditions to the total number of gas particles in the sample under the final conditions. So let's read up here. It says a sample of helium gas is in a closed system with a movable piston. Volume of the gas is changed. Okay, so basically you have a closed system and has a movable piston. And there's some, just gas particles in here. And what they did is they increased both the temperature, right? Temperature went from 200 Kelvin to 300 Kelvin, and they also increased the pressure from 2 atmospheric to 7 atmosphere. So we don't know what happened to the volume, but right now the first question here is asking about the total number of gas particles. So because this is a closed system, it doesn't really matter what we do to the temperature or the pressure. The total number of particles, because it's a closed system, no matter can escape, and so the total number of gas particles will be the same as well. Number 7, convert the final temperature of the helium gas sample to degrees Celsius. So pretty straightforward. This equation is in your reference table. So Kelvin is equivalent to Celsius plus 273. And so in our case, we know the Kelvin, so we want the final temperature into degrees. So the final temperature is 300, right? So we just write 300, and it's just some simple algebra. We can just subtract 273 to find our Celsius. So that should be 27. Boom. Number 8, in the space below, show a correct numerical setup for calculating the final volume of the helium gas sample. So this question right here uses the gas laws again. So it's the same equation that we talked about up here, and I'm pretty sure it's the same missing variable too. Let me just check. Yeah, because we're trying to find the volume of this one as well. So for this one, we would just plug in, so for P1, that would just be 2. For V1 right here, that would just be 500, and then for the initial temperature, just 200. Final temperature would be 300, and then final pressure would be 7, and then we can just solve for the final volume. And so you should get that. Alright, number 9. When the airbag inflates, the nitrogen gas is at a pressure of 1.3 atmospheres, a temperature of 301 Kelvin, and has a volume of 40 liters. Calculate the volume of the nitrogen gas at STP. Your response must include both a correct numerical setup and calculated volume. So this question is another gas laws question. Alright, so let's just set this up this time. So we know that it starts with a pressure of 1.3 atmospheres, has a temperature of 301 Kelvin, and 40 liters. So let's make this out like this. Boom. And then it's going to calculate the volume of nitrogen at STP. So STP conditions, you have to pretty much know this. It's on the reference table, by the way. So STP conditions, 273 Kelvin, 1 atmosphere, and then we're just solving for that final volume. So that final volume I've calculated right here, but you need both a correct numerical setup, which is this thing over here, and also the calculated volume. So I don't put units, but you probably should put units in the actual regions. But yeah, there we go, 47.2 liters. All right, number 10, balance the equation for the decomposition of NaN3 using the smallest whole number coefficient. So for this one, here's what I'd like to do. So let's write this out. NaN3 goes to Na, reduce process, boom, boom,